This week on Maker Update, a box for translating conversations offline, a dress for translating movement into light, a clock for translating light into time, and a toy for translating your voice into gibberish. Hey, I'm Donald Bell, and this is Maker Update, our weekly roundup of new and notable DIY projects and tips from across the internet. I hope you're doing well. We've got another great show for you. Let's get started with the project of the week. From the Creative Lab at Google, we have this offline universal translator. Fast automated language translation has been making big strides thanks to AI, but most advanced tools today live in your phone and require some form of data connection for translating in the cloud. So the challenge here is to see how well a self-contained, offline, large language model can handle translating multiple languages and, just as important, do it at a speed that keeps conversation feeling natural. Lucky for us, there's nothing mysterious about the hardware here. On their GitHub project page, which I'll link to in the description, they outline a list of materials that includes a Raspberry Pi 5 with 8 GB of RAM, a USB microphone, a speaker, and a display. Not mentioned, but obviously a part of this build, are 2 mechanical key switches and a rotary encoder. If you just want to test this with a generic computer keyboard though, the inputs are all mapped to standard keyboard keys. Because it's Google, this is meant to be a showcase for their Gemma 4 AI model and anti-gravity platform. In practical terms, what this means to me is that the installation and reproducibility of this code should be flawless. Everything is configured over the Raspberry Pi's command line interface. And though you don't need it to get it working or even just to test it out, the team includes STL files for the enclosure. And it's kind of a cool handheld enclosure that could be useful for other Raspberry Pi projects, even if you don't end up making this one. More projects. On Adafruit, Erin St. Blaine shares how she made this motion-activated light-up polka dot dress. And the polka dots are important here because those dots are where she's placing the LEDs. It's a nice combo because you get the white dot to diffuse the light and then the dark background to mask out any light that would bleed through. The project takes advantage of these addressable LED fairy lights. They're lightweight, color changing, and each LED is encapsulated so you don't have to worry too much about getting them wet. The board used here is an Adafruit RP2040 Prop Maker Feather. I expect you could make this work with a smaller, less expensive board, but this is a nice option because it has screw terminals for the LED wires and a built-in accelerometer for detecting motion. Erin's guide has every step of the build shown in detail and the full code for you to download. Another LED project that caught my eye this week is ChronoBloom by Joe S. This is a 3D printed clock project that uses an ESP32 board and WLED software for the LED animations. Behind the 3D printed frame is one of those nested or bullseye style rings of addressable LEDs, but diffused like this, those rings are completely transformed. The clock pulls everything from a dedicated web interface where not only can you set the time, but you have detailed control over how the look and motion of the clock changes throughout the day. For another fun, well-documented project on Adafruit, the Ruiz brothers and Liz Clark created this 3D printed voice changer and looper toy.
Hello, this is a test recording. Hello, this is a test recording. Hello, this is a test recording.
I'm a sucker for any kind of sound toy, but I think what I like most about this project is the interface. You get these 2 chunky knobs, the 2 buttons, the DJ style fader in the middle, and then the LED strip across the top. How do you resist picking this thing up and playing with it? Finally, a quick update on a project we featured last month in episode 490. OEO, the team behind the MurMur ambient sound speaker and algorithmic microcosm, they've now posted a build guide on how anyone can recreate their prototype. The guide doesn't include the code or instruction for recreating the little interactive world, but you get the list of materials and components, the 3D files, and code for loading and playing video on the display. Definitely a cool platform for making a little world you can take with you. Now for a few tips and tools. From Slava S on GitHub, a recipe for fitting a functional large language model AI on an inexpensive ESP32 board. It can't do much, it's more of a proof of concept, but it can generate tiny stories, or you can set it up to answer common questions about coffee making. Still, kind of crazy that it's possible at all. From Nich Fugal on printables, a design from 2024 that's new to me. This is a Gridfinity compatible storage carousel that can hang from your wall using a French cleat mount. A clever detail here is a 3D printed leaf spring mechanism in the back that puts the carousel in tension so that heavier bins don't always sink to the bottom. If you really want to take it to the next level though, Nich also published a motorized version of this design that looks like fun. For this week's DigiKey Spotlight, check out the latest video from Shawn Hymel on training a balance bot using reinforcement learning. This is an in-depth, hour-long look at what it really takes to train an ESP32-based robot using simulation, reinforcement learning algorithms, and multiple training phases. These are the same techniques used by researchers to train state-of-the-art walking robots. If you want a detailed yet accessible look at how it's done, this is the video for you. Alright, and that does it for this week's show. Be sure to subscribe, leave a thumbs up, or leave a comment. A big thanks as always to DigiKey for making this show possible, and thank you for watching. I'll see you soon.